When we were multiplying our complex numbers, something weird happened in this problem right here. When we multiplied 2 plus 3i times 2 minus 3i, we ended up with no imaginary part whatsoever. Well, that's actually a really important feature in complex numbers. These two complex numbers are called complex conjugates of each other. So let's look at that in more detail. Complex conjugates, for example, 2 plus 3i and 2 minus 3i, can be generalized by saying they're in the form a plus bi and a minus bi. So here are some examples. If I give you the complex number 2 minus 7i, what would the conjugate be? Now, what we notice about complex conjugates is that the real part stays the same, but the imaginary part is not the same. The imaginary part needs to change signs. So for my example of 2 minus 7i, the conjugate will keep the real number part the same, but we're going to change the sign of the imaginary part. So it will be 2 plus 7i. What about negative 3 minus 2i? Remember, we're going to keep the real part the same, and we want the imaginary part to change signs. So the conjugate would be negative 3 plus 2i. What about a problem like 5i? Well, really we have a real part of 0 plus 5i. We don't write that usually. So when we change to the conjugate, we're going to keep the 0 part the same, but change the sign of the imaginary part. So this conjugate would just be negative 5i. How about this problem? 3i minus 4. Keep in mind, this complex number is not in standard form. So first we need to think of it as negative 4 plus 3i, and then we can write its conjugate. Keep the real number negative 4, change the imaginary number to negative instead of a positive. So those are complex conjugates. We also have conjugates for radicals. And the main reason we need conjugates for radicals is for doing something that we call rationalizing the denominator. So we're just going to really work with conjugates for radicals in the denominator. And we'll be using this to rationalize the denominator another day coming up very, very soon. So the conjugate for a radical in the denominator works very much the same way as conjugates for complex numbers. So if I'm looking at 5 over 6 plus the square root of 3, the conjugate would be 5 over 6 minus the square root of 3. Here's another one. 7 over negative 8 minus the square root of 13 would become 7 over negative 8 plus the square root of 13. Now there is something interesting that happens if your radical is written in a different format, such as this problem, negative 12 over 5 square roots of 3 plus 2. There's actually two ways we can write this conjugate for our denominator. We could write it negative 12 over negative 5 square roots of 3 plus 2, where we change the sign of the radical term, or we could write it negative 12 over 5 square roots of 3 minus 2. So when you're working with radicals, it's most important that you just change one of the signs. It doesn't necessarily have to be the sign of the radical. Whereas with complex numbers, you really do want to change the sign of the imaginary part and keep the real number part the same.